Okay, so this is Superlab 2. This is the first of our layer 3 VPNs in Superlab 2. First thing to note is that, of course, the route reflector is off the data path. It's not running MPLS. Consequently, when multi-protocol BGP routes come in to the route reflector, it's not going to recognize them. It doesn't have an INET3. Consequently, it can't reflect the BGP routes. So we have set routing options. We have INET3, static route. And for the IP version 4, we're just accepting all the routes. We're effectively rejecting them. It doesn't matter. It takes the BGP live. The routes can be reflected. Okay, so VPNA has several sites. There are two sites that are using BGP as the PE to CE protocol. And then there are two sites that are using OSPF as the PE to CE protocol. And that's CE1 and CE2. Now, in this example, the connection between CE1 and CE2 is considered a backdoor connection, which we're not wanting to use. So we've put a metric on that of 50, and we're going to be running sham links so that the traffic from CE1 to CE2 prefers the iBGP. Okay, so let's look at the BGP VRF import and export. Well, they really do operate exactly as we'd expect. We are VRF exporting. Here's our policy. So policy options, policy statement, target export from OSPF, add the target, accept, from the direct, add the target, accept. And then on the import from protocol BGP, from that target that we've previously set, accept. Okay, the second thing we need to bear in mind with the OSPF is, of course, we're going to be using our VRF import and export. And as we've looked at several times, going VRF import from the BGP L3 VPN and VRF export to the L3 VPN is a relatively simple process. But because we're OSPF connected, we also have to remember that we need to export the OSPF out to the site. Now with BGP that's automatic, with OSPF clearly it won't be. So set policy option, policy statement to VPN CE1, turn 1 from BGP, then accept, and basically set routing instances VPNA, protocol OSPF, export to VPNA CE1. So what we're doing here is we're doing the VPNA export, the OSPF export out to the customer sites. Okay, so let's take a look at these sham links. Now, as we know, the problem with OSPF and BGP is that when the OSPF routes go into the BGP, LSA1s and 2s come out of the BGP as LSA3s. And this causes a problem because the LSA3 makes the iBGP connection look like a separate area. So it looks like an inter-area route rather than an intra-area route. Of course, OSPF, regardless of metric, will always prefer to stay in the same area, area 0. So therefore, C1 to C2 will choose to stay in area 0. We get around that by having sham links. And what the sham links do is they make sure that the LSA1s and 2s, when they go into the multi-protocol BGP, get dropped off as LSA1s and 2s. Okay, so how do we do the sham link? Well, the first thing we need is that in both router 3 and router 7, we need a unique IP address for the VRFs. So here we have it, set interfaces, LO0, unit 1, family INET address. We then put that interface into the VPNA, and under the protocol's OSPF, we say that our sham link local will be that unique IP address. And then the sham link itself comes under the area 0 because that's where it lives. So set routing instances VPNA, protocol's OSPF, area 0, sham link remote, and we put in the remote IP address there with the loopback. We're putting it a metric 1. And by having it as a metric 1, it means that C1 and C2 will actually prefer this iBGP connection rather than their own backdoor. Now, if that wasn't a backdoor, if that was just a connection between OSPF routers on the site, then what you would do is you would set the metric on this rather high, rather than having a metric of 1, and then it would prefer its internal. But for this example, these sites are considered, this is a backdoor we want to avoid. Okay, before moving on to the BGP sites, let's just have a quick look at the autonomous system number here. Now this is a 4-byte AS, as we know, it's 23.89. We're choosing to use an AS specific route distinguisher here. So rather than have route distinguisher ID set in routing options, we're actually typing it into the VPN itself. To represent the number, we do 65536 times 23 plus the 89, and then we insert an L to let the VPN know that this is a 4-byte route distinguisher, and we're using the same format on the target as well.